the type of chemical calculations you'll be expected to perform have to deal with 3 different types of amounts of atoms. So here on the slide are 3 different buckets in this flow chart that show you the different types of amounts. On the far left is the mass of a sample. So mass is one type of amount. In the middle is moles. That's another type of amount. And finally, lastly, is number of atoms, and that is a different type of amount. So you'll be asked to convert from one type of amount to another. So it's really, really important that you're very, very clear what type of amount you're starting with and which type of amount you're converting to, because that determines which conversion factor you'll use. If you're converting between mass and moles, you'll use the conversion factor of molar mass, and the molar mass for atoms is found on the periodic table. If you're converting between moles and number of atoms, then the conversion factor is Avogadro's number, which is always 6.022 times 10 to the 23. Now, on this slide, we have the 4 possible conversion factors that you might use for these type of calculations. So first, we look at molar mass. And the molar mass, 1 mole, and I chose nitrogen as my example, is equal to however many grams is stated on the periodic table. So 14.01 grams of nitrogen. That is the equality between mole and mass, and right below it are the 2 possible conversion factors, which each, on the left we have 1 mole of nitrogen, on the top 14.01 grams in the denominator, and here we have 14.01 grams in the numerator and 1 mole in the denominator. Which one of these 2 conversion factors you use depends on what value you're beginning with and what value you want to end up with. For example, is the question giving you mass and you're trying to convert to moles, or is the question giving you moles and you're trying to convert to mass? So you want to set up these conversion factors so the unwanted units cancel out. And then on the bottom part of the slide, we have the 2 conversion factors for the relationship between mole of nitrogen and number of atoms. On the left, we have mole of nitrogen in the numerator and 6.022 times 10 to the 23 atoms in the denominator. And next to it, we have the conversion factor of 6.022 times 10 to the 23 atoms in the numerator and 1 mole in the denominator. So which of these 2 conversion factors depends on, is your question asking you to go from moles to number of atoms, or are you given number of atoms and asked to go to moles? So we're going to look at some examples of using these conversion factors, but it's relatively simple to get these conversion factors. You just have to practice applying which of the 2 ratios you use, and it will take a little minute to get used to if you've never had chemistry before, but I guarantee you with practice you will absolutely get it.